welcome back to video number 4. Well, we finally made it. We created the beginning of the program, and we was able to dump it into the processor of our PLC. We did come across a battery issue, which will take care of that first thing. But from here on out, we're going to learn more about ladder logic and hopefully get you all learned up on how to do more stuff like this.
To be fair.
Let's be sure to subscribe to my channel. Let's get started. Alrighty, first things first, let's replace this battery. So the importance of the battery is if this battery is dead, like the case we have here, if power is disrupted, we lose our program. So we will go ahead, whoa. Now we don't want to do that first.
I almost nunchucked you, you don't even realize.
Ouch.
Now, we can change this while the power is still on it. So, there is a 2-pin plug we can unclip. We'll pull the battery out, and then we'll take the new one, and we're going to install it like so.
"60% of the time, it works every time."
That doesn't make sense.
And there is no need to reset anything. The battery light will go away. Okay, so now let's go learn some ladder logic. Okay, so we will just continue on with our test bit we placed here earlier. This is rung 0. Many rungs will look like a ladder, hence the name ladder logic. So this is an XIC, examine if closed, which I like to look at as a true or false state. This is the OTE, output energized. From left to right, if the statements are all true on the ladder, then the output energized will come on. So now we will go ahead and make the test bit, the XIC statement, true. The OTE will turn on. As we toggle it back off, the OTE will turn off. So we will go ahead and create a new rung. We add 2 XICs to this one with an OTE at the end. The first XIC will be the test bit 1, and the next one, test bit 2. We will also make the OTE on the end, we will call it light 1. So all the new tags, they're currently undefined, so we will need to make these tags. We'll just go ahead and right click and select new, and we'll make sure we check the data type as a boolean, because a boolean is a 1 or a 0, 1 being on or made and 0 being off or not made. So we're going to leave test bit 2 undefined to show you what will happen if a tag is well not a tag yet. Alright, now we check it and we get an error. So that means we'll go ahead and define the tag and try to accept the rung edit. So once we accept the rung edit, then the next step is to test the rung edit. That's the lightning bolt icon. If testing is done or no need to test, go ahead and select the green assemble icon and the rung will be complete. We'll go ahead and toggle a few tags to see what will happen. Then the OTE will be energized on rung 1 when the test bits 1 and 2 are both true. Alrighty, so we're going to add a new rung here. We're going to start off with an XIC. We'll try out the XIO and we'll put in an OTE. So the OTE, we'll call it light 2. We'll go ahead and define this as a tag. And yes, it's a boolean, so we'll create. And here's the XIO, but we're going to skip it for now to go to the XIC. So for you to see with an open bit like this, we can actually grab an XIC from another rung and just drop it onto this icon here. Now, the XIO is an examine if open, which I like to call it true if off. So like if there was a switch and it was an XIO, then if the switch was off, then this would be a true statement. So we will call this test bit 3 and we'll go ahead and define this. We'll create. Okay, so look at this over. I may want to swap out these tags before I mess up. We'll just use test bit 1 and then use test bit 2 for the XIO. Now we should be able to accept it and test it. And now we'll go ahead and toggle a few bits here and we can watch the operation of what all happens. Alright, to turn on light 1, we have to turn the test bit 1 on. And we got true statements all the way across, light 1 comes on. So we'll go down to the next rung. So test bit 2 has got to be off, so we can actually either toggle it here or we can toggle it in the next rung. And we'll toggle it off. So with test bit 1 on and test bit 2 off, our light 2 comes on. Toggle test bit 2 back in the on position. Light 1 comes on, light 2 goes away. We'll go ahead and assemble this rung.
I'm gonna be honest with you, you look like a succulent baby lamb.
Okay, on to rung 3. We will put in an XIC and an XIC and an XIO. And why not? Let's try out a latch. So when a latch becomes true, it becomes locked in until an unlatch gets triggered. So let's reuse some of these bits we already have made. On to the latch. Alright, so we will call this latch 1. And we'll go ahead and define this. Although it's a latch, it's still a boolean. So we'll hit create. So let's go ahead and accept the rung and we'll test out the rung. Alright, so it's time to make the statement true. We'll take test bit 1, we'll turn it on. The test bit, turn it on, and test bit 2, we'll turn it off. And as you can see, the latch is now made. So now as we break the statement on rung 3, the latch will stay on. Alright, so it looks good now to assemble the latch. Starting another new rung, we will add in an XIC. We'll use test bit 3 that we made earlier that we wound up not using. Now we will add in an unlatch. No need to make a tag for this as we will use the latch 1 tag as it's already associated with the latch. Let's go ahead and accept and we'll test it. As you can see right now, the unlatch is on because the latch has already been made. We will go ahead and re-trigger the latch to be on. Now we will break the statement. So the latch continues to stay on like we saw last rung. But now we will toggle test bit 3. The latch has now become unlatched. We will toggle test bit 3 back off and the latch stays. Let's assemble this rung. We will now go ahead and add in a new rung. We'll also put in an XIC. And we'll give it a timer on. So for the XIC, we'll make a new tag. We will call it test bit 4. And let's not forget to define the tag. Once we get to the timer, we'll also need a tag as well. We'll go ahead and call this thing timer 1. And we'll also have to define it. And you'll be able to see that the data type is going to be a timer and not a boolean. So when the rung statement is true, the timer on bit will come on and run up to the preset time that it's giving. Timers in RS5000 run off a millisecond, so a 5-second timer will need 5000 in the preset. We'll once again accept and test. So toggling test bit 4 here makes the statement in the rung true. The timer is now going to be timing up to 5000 milliseconds. But once done, the timer stops, the done bit is made. Time to assemble the rung. We'll make a new rung here. We'll just drag down an XIC to show that there's another way that we can do that. So let's make this tag be timer 1, as it's already a tag. But for a timer, there are other choices that we can use in the logic. So we will use the drop down and use the expand button. Here you can choose what part of the tag we want to use in the rung. There is a preset, an accumulation, an enable, timer timing, or a done bit, which we will use. So then we now want to use an OTE for when the timer is considered done. We will just make a new tag and call this light 3. And we will also define the new tag. So we'll go ahead and accept and test. Alright, so we will toggle test bit 4 to clear the timer. And then we're going to toggle it again to restart the timer. Now, as you can see, we just created a 5-second delay timer. And we'll go ahead and get this assembled. So now let's create a rung for a timer off delay. We will start with an XIC, and then we'll add in the timer off. We'll go ahead and call this timer timer 2. And it's a new tag, so we're going to have to define it. And we'll go ahead and make the preset to 10,000 for 10 seconds. Alright, so let's use the tag test bit for the XIC.
And there seems to be no sign of intelligent life anywhere.
Actually, I was thinking, let's change that to an XIO. Alright, so we'll accept the rung. And we'll test it. So now when we toggle the test bit, the timer is now enabled, but it's not timing. We toggle the test bit again, which breaks the rung statement, and now it begins to time. We'll go ahead and assemble this rung. And we're adding in another rung. This time we will use a counter up. And let's see, let's use an XIC in front of it. And we'll make a new tag and call this test bit 5. And we'll go ahead and define it. And the counter, it will also do a tag as well. And then we'll just go ahead and call this count 1. We will need to find it, and in the data type, it's going to be set to counter. So we'll go ahead and create it. And now we'll just set the preset to 5. And here we go again. We will accept the rung edit and we're going to test it out. So now we can toggle the test bit 5 and it will count every time it comes on. So if I press the Control T, that's the quick key instead of using the mouse to toggle on and off. And it will continue to count even after the preset has been made, but the done bit will stay on. We'll go ahead and assemble it. Alright, well, we'll go ahead and add this rung. We'll, let's use an XIC and an OTE. So we will use the tag count1 and we'll use the counter's done bit. So on the OTE, we'll make a new tag and let's call it goal achieved. And we'll go ahead and define that as well. So when we accept the rung and test it, with the count 1 done already made, the goal achieved OTE will already be on. So let's just go ahead and just assemble it and move on to a countdown counter. So we're going to go ahead and add in this rung. And we're going to go ahead and select the countdown. Okay, so we're going to go ahead and name it count 2. We'll define it. And we're going to, let's see, for this preset and the accumulation, we'll set them both to 10. Alright, so we'll go ahead and put an XIC in front of it. And let's see here. Test bit. We'll go ahead and use test bit 2 in place of it, and we're going to go ahead and accept and test it. So we will go ahead and toggle the test bit 2 on and off. And there the counter is counting down from 10 each time the bit is toggled. But now we can actually use the green arrow on the top besides the symbol to just skip the accept and test and assemble to finalize our edits. Alrighty, so we're going to add in a rung here and we're going to look for a reset bit. That's one thing we don't have yet, is a reset for our counters. So for the tag name, we're going to use a counter that we already have, so it'll be a counter 1, or count 1, sorry. And we'll put an XIC in front of it. And we'll call this XIC tag, we'll call it reset 1. And of course, it's going to be a new tag, so we'll have to define it. And our reset is already a tag, so no defining there. Alright, so we're going to go ahead and accept. We'll test it. And we'll just go ahead and assemble it. Okay, so our count 1 has an accumulation of 6 right now. So if we reset, okay, now toggle, and it will go to an accumulation of 0. So good, it reset our counter. We'll just go ahead and toggle test bit 5, and it works, yes. Went to an accumulation of 1. Alright, so that should be it for this video. Hope you all enjoyed. We'll see you next time.